Hi, welcome to the second video of Mininet. In the last video, we talked about the advantages of Mininet, and the idea in this video is to start using Mininet. So, as we said in the last video, there are three ways to use Mininet: the command line interface, Python application, and a graphical user interface. We're going to see these first two ways to use Mininet, as the graphical user interface is not as flexible as we would like it to be to work with Mininet. So first, let's go to the command line interface. We have here some uh, command line commands to start the Mininet, let's say, program. But first of all, let's open the virtual machine of Mininet. Remember that in the website of the course, you have the virtual machine of Mininet, which you can install with an hypervisor like VirtualBox, for instance, and you can work with this virtual machine that is available for you there. So I am here in the virtual machine. The virtual machine, if you look at the interfaces it has an interface called ETH0, which is an virtual interface created by the virtual machine to connect to your physical machine. You have there the internet address, and I will connect. I am on a Linux machine. I will connect via my terminal. You can connect using terminal or in Windows, the virtual machine. So I will use an SSH connection to connect to the virtual machine. Okay, so this is the username is Mininet of the virtual machine, and I will connect to the IP address. So then I am here inside the virtual machine. I will run actually a command to see Wireshark in my virtual machine. So I will run the Wireshark software in the virtual machine. Here, just to show you that if I capture the traffic on the loopback interface, here in Mininet, when I start Mininet, the loopback interface is the interface that is used to connect the virtual machine with the controller. So if I start a very simple Mininet count here with sudo mn, I will see here, let me stop the capture, and I can see here some open flow packets, actual open flow packets. I can see here, for instance, using the actual OpenFlow protocol that we already saw. So the OpenFlow protocol is actually used in the virtual when I open the Mininet program, and those messages, OpenFlow messages, are sent between the controller and the switch in a Mininet topology. I will show you how to use the Mininet topology right now. So let me quit here. I will exit Mininet here, and I will show you. Let me put this with a bigger font size. I will show you some options to enter to Mininet. Okay, so in Mininet, one enters to the Mininet command line interface with the mn command. So I can here from the virtual machine, I always should use the sudo permissions, which has all the permissions of the administrator in a Linux account. If I put them in, so I enter to the Mininet virtual machine, sorry, to the Mininet program, and in its easiest format, you create the easiest network that you can have with Mininet, which is a network with one controller, two hosts, host 1 and host 2, and one switch. And the connections in the network are connections such that you have the connection of the host 1 with the switch 1 and the host 2 with the switch 2. So it is just a network with two hosts, and each host is connected to the switch. So you have two hosts, one switch, and one controller. So here now you are in the SDN, in the Mininet command line interface, and you can use several commands. One command which I recommend you to use is the help command. The help command will show you all the possible commands that you can use in Mininet, which are all these documented commands that you can see here. And if you want to know how to use any of those commands, you can also use the help to do that. For instance, help net will tell you what the net command does. Okay, I will show you some commands here that I have already prepared here to show you how the command line interface of Mininet works. So for instance, if I use the nodes command inside the command line interface, it will show me the nodes that are already active in the Mininet environment. So you have the C0, which is the controller, you have the H1, host 1, and you have the H2, host 2, and S1, which is the switch one of Mininet. The good thing is that each of these hosts or nodes are actually virtual machines or containers inside the Mininet environment, and you can use them as if they were isolated virtual machines or isolated machines. The net command in Mininet will show you how the network is formed. So you have the first host H1. The first host H1 has the ETH0 interface and is connected to the ETH1 interface of the switch 1. The host 2 has also an ETH0 interface and is connected also to the ETH2 interface of the switch 1. And then you have a loopback interface in the switch, and also the interface 1 connected to the host 1 and interface 2 connected to the host 2. And then you have the controller. So the net command shows you how the different nodes of the topology are connected. You can use the command dump that will show you more information about each node. For instance, the host 1 is a host, has one interface ETH0 with this IP 10.0.0.1, and the process ID, which is the process of the container actually. Same for host 2. Switch 1 is not as S1 is not a host, it's an open vSwitch. And it has the loopback interface, the S1 ATH interface. It doesn't have an IP address as it is a switch. And a switch interface is a switch of layer 2, which does not have a IP address. I have the controller C0, and this controller also have the loopback interface that is the one that connects the controller to the switch. Okay. One good thing about Mininet is that if you put first the host or the node that you want to control or to see, you can use any Linux command to see things of this, for instance, host. So you can see ifconfig, and it will show you the configuration, the network configuration of the host 1. Same for host 2. Actually, you can do the same for switch 1. It will show you the loopback, the two interfaces that it has, right? And even for the controller, you can do that. So any actual command you can use in the nodes. You can use, for instance, ps to see the processes that are running in the host 1. And these are the processes that are running in this host. Okay, the Mininet, for instance, is one of the processes. So each node acts as an independent machine that you can configure and use and see in the Mininet environment. You can use, for instance, the ping. So H1 wants to ping H2. And you see that the connection is done. Actually, the switch is already configured with connections. So H1 is able to ping H2. Same should happen with H2 and H1, right? So you can have a ping from H1 to H2 or from H2 to H1, because the switch is already actually in this just it's a simple configuration of Mininet. The switch acts as a hub, so it has connectivity between all the hosts that are actually connected to the switch. There is another very important command in Mininet that is called the ping all. The ping all, you can see that all the hosts in the network try to ping all the other hosts, and you can see if there is reachability between or among between any pair of hosts in the network. Okay, these are the main commands. You can go to the API of Mininet to see more commands, or you can use the help and see any of these commands and see how to use them. But these are the most important ones that we're going to use. With the exit command, you exit from the Mininet environment and you go again to the virtual machine. Here I can use this another command, sudo mn-c. When you call the Mininet with -c, you clean all the things that you already did in the Mininet environment. So you can start again Mininet with a new topology because everything is already cleaned. Okay. So if we go again here to the slides, these are the functionalities that we can use to start a Mininet, let's say, session in the Mininet environment. Let's see some examples. We already saw the sudo mn, but you can use, for instance, also the --topo argument to use different topologies of Mininet in the tests that you want to do. For instance, I can use this sudo mn --topo single and with the argument 3. And what Mininet does, it creates a network with 3 hosts, so H1, H2, and H3, and one switch. The switch 1 and is connected to all nodes, so H1 is connected to the switch, is connected to the switch, and H3 is connected to the switch. And then you can see also for each host, you can see the configuration of the interfaces. You can ping, for instance, from H1, you can ping H3 to see if it works, or you can use ping all to see who is connected to who. And we can see here that everyone is connected to everyone. Actually, I can again clean a little bit the topology and use again the sudo mn --topo single, but not with 3 hosts, but for instance with 6 hosts. It will create 6 hosts. As you can see here, create the links between the 6 hosts and the switch 1. And if I want to see the connectivity, I can see that host 1, for instance, can ping host 2, 3, 4, 5, and 6. Combination go here. So here you have actually a very nice test, environment test, to create a network and to test connectivities and so on. Okay. There is another topology which is actually nice to see, which is not the single one, but the linear one. The linear topology is a bit different. Let's put a linear of 3 nodes. And look what happens. You have 3 hosts, H1, H2, and H3, but you also have 3 switches. And each switch is connected to its respective host. So host 1 connected to switch 1, host 2 connected to switch 2, host 3 to switch 3, and then the switches are connected between or among them. S1 is connected to S2, and S2 is connected to S3. So if I can put a graph here, the linear topology is something like this. Let me put this in the full screen. So I have a controller that is actually connected to all the switches, and host 1, for instance, is connected to switch 1, host 2 to switch 2, and you can do the linear thing up to n switches. Switch n will be connected to host n, and the switches are connected among them. So this is the way to create a linear topology. Okay? So you have linear, you have single topology, and there are more opportunities to create bigger topologies. Okay, so more than the command line interface, what happens if you want, for instance, to create custom topology? Then you have to use the Python API and not just the command line interface. The command line interface just create predefined topologies or predefined environments. But the core of Mininet is actually a Python API, which is actually easy. It's used for orchestration and for emulation and for customizing the programs that you want. And more information, as you can see, is here, the mininet.org web page that I will open now. Let me open mininet.org. In mininet.org, you can have all the information that you want from Mininet, not just the one that I will show you in this class, but you have everything, for instance, getting started, downloading also a Mininet virtual machine, having a walkthrough, and you can have also an OpenFlow tutorial. And you can have actually more information than the one that I will give here in the course of if you want to have a wider knowledge of Mininet and the API, you can come here. Here, actually, you can find the Mininet CLI and API. So if you the walkthrough of the CLI show you more or less what I already showed you, how to use the commands, how to use the processes, the pings, and so on inside the Mininet environment, and more, right? Advanced options and so on, how to use the iPerf and several more options that I actually encourage you to go and use here in the Mininet walkthrough page. Also here, there is the Python API reference manual. So I will show you some small examples on how to use the Python Mininet API, but if you come here, you have all the information of the Mininet API. Okay, all the classes, all you can use. Well, okay. So again, please try to go and use the Mininet API. So let me go again to these slides. So here there are some important classes, methods, and variables of the API. You can go to the Mininet web page, but here you have a lot of the most important things that we are going to use. So there is a basic class for Mininet topologies, which is called topo. And you have the add switch method to add a new switch to a topology, add host method to add a new host to a topology, the add link method that adds a link to the topology. And you have the Mininet, which is the main class to create and manage the network, the start method that starts your network, the ping all method to test that your network is actually running fine, right? The stop that stops your network, and some other methods and variables. As I told you, these are the principal ones that we are going to use, but anyway, you can go to the Python API to see how it works. Okay, there are some like low level or basics of the API in Mininet, and there are more high levels, which is the one we're going to use. So here in the slides, you have some examples. For instance, to create this simple topology with 2 hosts and a switch, you just have to create in a Python file this net equal to Mininet to create the network. You can create the host 1 and host 2 and assign them with the add hosts method to the H1 and H2, the same with the switch 1 to the C0, which is adding the controller. Then you can add the link just between host 1, switch 1, host 2, switch 2, and put in net dot start that this network will start. So I encourage you to please try to create this Python files and run them to see how the Mininet environment works for you guys there. There is another one of performance modeling in Mininet. I also encourage you to go and see how this works. The low-level API is what I just showed you. The middle-level API is using also the add host, add switch, and add controller methods. But what I am most, let's say, interested in showing you is the higher-level API. The higher-level API, you can see, you can actually create the classes with the customized topologies that you want. This is the example of a single switch topology. So remember when we created the single topology, and which was just a topology with the number of hosts that you want, and they are connected to one switch. This is the code for this. So in the next video, we'll see in more detail this high-level API of Mininet, and you will have an exercise to work with and to work in this high-level API. So thank you very much for your time, and we will talk in the next video.